next move to Dhairya, and we would really love to hear now, moving to another region of the world, about the work that you've been doing with the Alliance for a Green Revolution in Africa, or AGRA. Mm-hmm. And you've been building with 12 nations a policy hub in the agricultural sector. So this caught my eye because in our Climate Governance Commission, we commissioned a report on the potential and possibility for a global climate policy clearinghouse, which could be a space of innovation, sharing, learning among nations, among other jurisdictions, policy actors, subnational, to really accelerate the policy thinking to drive the necessary changes. So when I heard about what you were doing with AGRA, it really mirrored, what we were thinking at the global level. So we'd love to hear about this policy work that you're up to.
Sure, thanks, Maya. So yeah, actually, Maya and I connected earlier in May, and she sent me this white paper report on the climate governance work she was doing. And I read this term called Global Clearinghouse in that report. That's the right term, correct? Clearinghouse.
Yeah, Climate Policy Clearinghouse is working title.
I read the description of that. I'm like, we are doing this already, but in agriculture, and a sub part of it is climate in Africa. So what are we doing? 6 years ago, I started working in Kenya with a bunch of farmers in a small county called Kangema. It may not be easily showing up on the map if you look it up. We started working there, and we saw that a lot of these farmers, and actually a lot of NGOs and from all around the world were already there. And they were talking about, let's use data to change how you do farming. Let's improve access to markets. Let's make more nutrition food, but use data to do all of this. And the farmers are like, what? It started from there. And I'm like, okay, that's interesting. I'm an engineer. And I'm like, okay, let's use my engineering. By the way, I'm not very proud about it, because I was taught to think very linearly. So if engineers in the room, I'm sorry for you guys. I'm sorry for myself. But I recovered from that very quickly. So yeah, as an engineer, I was taught to think very linearly. You have a problem, data looks like a solution that's proposed. Let's create some database solutions. But then we realized the farmers don't care. They've been doing things for a while, and also the data sets I'm talking about are at a macro level. I'm talking about data sets coming from European Space Agency, NASA. There was an agency in Kenya called RU Forum. They were doing all this mapping, amazing stuff. Boeing was using this to do precision agriculture, all of this good stuff for private sector companies. But what about these farmers at a ground level who've been farming, small, medium holding farmers who can't afford really these big solutions? So we started creating something called as a farm hub for agriculture, a very small solution to allow farmers to collect their own data using very cheap sensors, and now pushing this data in a local hub sitting in that county itself. And who actually takes care of this data processing, and who does all of that? The young people. So the young people in this county, if you go and ask them, do you want to work in agriculture? And they're like, hell no, I don't want to be wearing gum boots, and I'm not 50-year-old. That's the average age of a farmer in Kenya and around Africa. I don't want to do anything with agriculture. I'm going to get my degree in some kind of tech and just go to US or Europe for better job opportunities. Nobody wants to work in agriculture if you're 20 especially. And then we tell them, what about working on open data sets provided by European Space Agency, hacking those data sets to create some solutions for farmers in your county? Now they're interested, because now we are talking tech. And they thought agriculture was about wearing those boots and getting into the farm. These people have never set foot on the farm. That was my first foray into using some kind of technology to actually work with the farmers. That was 6 years ago. I had to give you that story because that set up the whole tone for what we are doing now in 12 African countries. We scaled that model from a small county to around 12 countries for now. After we started getting this data over 6 years, we started creating the solutions, and it's at a very small level so far. And then we suddenly meet this organization through some series of really fortunate events, and they tell us that we want to do this kind of work at a policy level. We have a lot of data, by the way, from the governments, from even now farm level. We want to take all of the data, create some machine learning models. They don't know what they're talking, by the way, but they come to us. It's so popular to just come and say, I want something on machine learning that uses blockchain to give me optimized output. I'm like, wait, you clearly are reading a lot of blogs. Good for you. Let's just take a step back and let's figure out what is the goal, what's the purpose. Somebody talked about purpose here, people, right? Let's talk about people. Who do you want to affect? And they said, we want 30 million farmers in these 12 countries to be positively impacted by the policies the governments are making. Can you build a tool to do that? I'm like, now you're talking. Okay. Now first, let's trash all the tech from here. I'm sorry, you brought me to speak about tech, but I'm going to just put the tech on the side. Let's focus on people. So we started focusing at a micro level. How much data do we have at a micro level? What do we know about avocado farmers, coffee farmers, tea farmers? We started getting this data from local county level. Now we have all the policies. By the way, the partner we are working with, they give us full access to last 10 years worth of policies from these countries. All these policies, some of them in paper format, were digitized using a tool that we had, translated in real time, put it into a document. This is an ongoing project right now. And now we are creating an algorithm to start looking for key buzzwords and actually seeing the impact, historical impact of these policies that were put in the place 5 years ago, and what was the impact of that policy on a coffee farmer in a county in Kenya or in Tanzania. And we have now results. We actually know what worked and what didn't. And now we are using to train a model to start making predictions to help people make better policies. People, government, so interchangeably used. So that is a very simple project that we kickstarted a couple of months ago, actually, the 12-country model. And we are now realizing that we have the micro data from the farmers. We have the macro level data from government level. What we were now starting to miss was meso. So what we started doing is we started categorizing the policies into 3 different categories: micro, meso, and macro. And we started creating data sets at all 3 different levels. We started pushing them into really small buckets, because otherwise, anyone here who works in data, you may know, we are in the world of open data and there's so much happening. You look at them and it will make no sense to you. Oh yeah, the data is open. We have 10 years worth of climate data. What do I do with it? You tell someone there's going to be 1.5 degree increase in climate in your region, that's going to be really impacting your harvest. And they're like, no, it's fine. Yesterday it was so cold and nothing happened to my crop. So 1.5 doesn't seem too much. But this is not how, humans think in general. But the models that we are building right now are not thought by humans. The basis of it is human intelligence, and that's where the AI comes into picture, because it can take so many factors that's beyond typical human comprehension and starting to make these predictions, eventually with a very simple goal to make better human-focused policies, which you spoke about again. And again, as an engineer in the room, I was listening to gravity, and I really like, those words. It just kicks me. And then you talked about speed. Now, the physics in me really would take it to the next level. Not just the speed, but the velocity is important. So speed is of course there, but the direction in which we are moving. You can be moving very fast in the wrong direction, which we have, by the way. So let's face that. So we have the speed, and I think you had a wonderful line, Lars. When we have very little time, we have to come up with solutions quickly. AI can allow us to do that right now, which is why we are building this platform to take in all of these policies, because we do not have time to hire 10,000 interns who can work on coffee and pizza and go through these documents and tell us, oh, stop doing this. This is what's going to work for the world. We need machines to do that. And AI is allowing us to have this complex data being processed at a speed that's unimaginable, and allow these governments who otherwise cannot make these decisions, which may be affected by political changing landscape. By the way, this AI policy also takes care of all this catastrophic disasters that happen around the world. It accounts for all of that and starts giving you these small outputs. So that's a very small project that we are developing for agriculture. It has tones of climate, it has tones of youth employment, all of it. And when I just heard about climate governance project around global clearinghouse, it was very clear that we need some similar solutions for climate policies to help us make better policies. I mean, I was listening about the policies that is going to allow Swedish to have adoption of like 50% EV or maybe 90% EV in the next 3 years. What is that policy? How did that happen? We want to know about it. Why is it working? And if it's working, why are other countries not doing it? Who is going to share that? This system is actually meant to share the successes and, most importantly, what's not working. Some of the countries are straight up repeating exactly the same mistakes that have been done by other countries. Let's avoid them. Let's make new mistakes. We're still going to make them, but not the same ones. And that's why these models are important. And before I end this and open up the floor later on for other questions, I do want to say, by the way, I'm not propagating that AI is going to solve all of this. In fact, I want to end up with the fact which some of you may not know, but if you really want to use AI, there's a recent, I don't know, I think 2019 there was a paper, and I can find the exact name of the author for you if you come and see me later on. 2019, there was a paper that said AI typically consumes 280,000 kgs, I use kgs, of CO2e, not CO2, CO2e, which means CO2 plus all this other nitrogen and methane and all the other gases. That's how much it emits to train one natural processing algorithm using machine learning, just one algorithm. That's 5 times more than the lifetime of a car. So we are using AI, I mean, there's a whole irony here. We are using AI to help climate impact, but AI itself consumes insane amount of energy. So we still need to think it in terms of a larger system, the impact of using AI and tech to fight climate change while creating more problems. So I want to open up with that thought for all of us to think. And thank you again for having me.
Thank you. Yeah, fascinating. Wonderful.